Hi everybody, Mike Ward here with R3. We're going to get started in just 1 minute, so we'll be back on in just a minute. Let everybody get connected. Hi everybody, Mike Ward here with R3. We're going to get started in just 1 minute. Hi everybody, Mike Ward with R3 here. We're going to go ahead and get started. Thanks everybody for joining us. Got a couple things that we're going to run through today, take you through the agenda. I'm going to run through some miscellaneous items, a few housekeeping items, and just some small things that are in the news. Anthony Lewis from our Singapore office is going to take us through the Singapore FinTech Festival. Guy is going to take us through standard transaction performance measurement. So this is kind of a hot topic in the DLT space is measuring performance. So we wanted to make sure that we talked about how structurally to do this. And then last is Joel is going to do a demonstration of the new observer node capability that was released in the 2.0 release a couple weeks back that we've been talking about in anticipation. So just a couple housekeeping things here. So first, again, as we always point out, we are streaming this live on YouTube. So if you'd like to follow along, you can use YouTube as an alternate way to view this. Additionally, all of these AWG sessions are available up on YouTube immediately after the session. You can go back and view the older AWG sessions if you're interested in some of the prior content. So the bit.ly link to the YouTube page is up there. You'll also find a number of other videos up on the YouTube channel related topical areas and et cetera. So we try and keep that up to date for you. If you have questions, put them in the Q&A window or the chat window. We'll monitor both. I think moving forward, we'll only have the chat window just to keep things simpler. And if you have feedback on the AWG call, or if there's particular topics you want covered, feel free to drop me an email directly. It's mike.ward@r3.com. Just a couple things for Corda the news or some things that are coming up. First off, if we haven't mentioned this yet, we are planning to be in Japan. The anticipated date, mark your calendar, is March 7th. So we'll have a CordaCon in Japan. We'll have a number of our engineers, as well as the partners doing work on Corda present. So if there's things you'd like to see at that session, we'd love to hear about it. We'd love if you met us there in person also. So we'll have more information up on the Corda.net website once we have the specifics nailed for that. But again, March 7th in Japan, mark your calendars. And then again, the usual reminder, Corda Enterprise will be in private preview at the beginning of the year. And we want to have people register their interest so we know who we can have give access to that program to. So if you head up to Corda.net, you'll see a banner at the bottom of the page, and that'll link you to the registration form. And then we'll start to communicate more information directly to that mailing list in coming weeks. So first up, we have Anthony Lewis, and I just need to make Anthony a presenter. Anthony is going to talk about the Singapore FinTech Festival. Sorry, Anthony, I don't have control. Just 1 second, we'll give Anthony control, and he's going to take us through the Singapore FinTech Festival. For those of you who didn't see it in the news, it was quite a large FinTech or festival, obviously around financial technologies, sponsored by the Monetary Authority of Singapore, among others. So Anthony is going to take us through what R3 did there, as well as what he saw at the event itself. Hang on 1 second, we just got to give Anthony control. Okay, Anthony, you should be able to talk. Let us know if you are there, and we will put your slides up.
Hello.
There you go, Anthony.
Fantastic. So FinTech Festival, Singapore FinTech Festival, it's in its 2nd year running, and it attracted more than 30,000 participants. So it was a week-long festival organized by the MAS. The MAS is Monetary Authority of Singapore. It's actually quite a special authority because it combines both the currency issuing part and the market infrastructure part, and the regulatory part. So in many countries, there are separate organizations for these functions, but in Singapore, it's all part of the MAS. So this was organized by the MAS and the Association of Banks in Singapore. So that's the private sector association. Compared with other events going around the world that people may have heard of, Cybos had around 8,000 attendees. Money 2020 had about 10,000, and this FinTech Festival sold more than 30,000 tickets, about 3 to 4 times the size of other events. It's putting Singapore on the map with regard to FinTech, anything to do with FinTech, and it was a week-long event. The first day was a bunch of lab crawls, so you could go into various banks and companies and see how they do their design and their lab. And then there's 3 days of conference with booths and multiple tracks of talks. It was impossible to see everything. And then the final day, there was some accelerators and some competitions, and we participated in pretty much every single day. So next slide, please. So this was the first time R3 had a booth. So we had a booth on the main floor. It was right next door to the MAS booth and the ABS booth, very close to HPE, our partners. And not only did we have live demos and people staffing the booth all day and constant traffic, we had a private meeting room as well, so we were able to hold several confidential discussions with either partners or central banks or clients. So this was run and staffed for the full 3 days, non-stop, I have to say. Next slide, please. One of the major announcements was Project Rubin. So Project Rubin is a Singapore-based project run by the Monetary Authority of Singapore. Phase 1, we've participated in every phase so far. Phase 1 was last year. Phase 1 was getting a few banks together to explore what it would be like to develop a token on a distributed ledger, and the token represents Singapore dollars. So this would be a central bank issued digital currency on some form of blockchain. That was phase 1. That was on a private version of Ethereum. Phase 2, they did away with that because of all the privacy implications. Phase 2 is slightly different. Phase 2, they compared 3 different technologies. So IBM Fabric, JP Morgan's Quorum, and R3's Corda were compared side by side. And the idea was to see whether in a decentralized peer-to-peer interbank payments network, whether you could achieve liquidity savings in the same way that you can with a centralized real-time gross settlement system. So the idea is if 3 parties, at a simple example, if 3 parties need to pay each other in a cycle, but they don't have enough money to pay each other. But if you can see some sort of netting situation where if you netted the payments off, then actually the money can flow. That's called a gridlock, and with a centralized real-time gross settlement system that we have, you can resolve those gridlocks because the RTGS can see exactly who needs to pay who, and it can do the maths and it can resolve these. But in a decentralized system, where the point is you can't see other people's transactions, how might that work? So that was the premise of the project. The project is phase 2 is finished now. It's open sourced. So what does that mean? Both the project documents, the design documents have been open sourced. They're online to download. You can see the links there, bit.ly/Ubin 2017 report, RPT. But also the source code of the 3 different architectures and the 3 different results is bit.ly/Ubin 2017 codes with an S on the end. So that's available. You can go to GitHub. You can download the code. You can fork it. You can submit pull requests, etc., etc. Project Rubin was announced by Ravi Menon, who is the managing director of the MAS, so he's the most senior person, as part of his opening speech. So it's really a big deal for Singapore, and it puts Singapore in the lead in terms of how central banks are exploring and developing on distributed ledgers for their own specific purposes. So since then, 23,000 downloads of the report. That's fantastic, and it's probably higher now. Probably about 1,000 views of the Ubin source code, and they had a special booth. You can see on the right hand side. There's a special Project Ubin booth, which again was non-stop, and tons of people trying to find out what it is, why it's relevant, what the next steps are. That includes many central banks as well as exchanges and bankers. So it generated a huge amount of interest, and that drove some traffic to R3's booth as well, because people were very interested in the Corda solution, which was obviously architecturally different to the other 2 solutions. But you can see more about that on R3's blog, r3.com/blog. Next slide. We also ran a 2-hour workshop with our partners Accenture and our lead bank Credit Suisse. So this was in a packed room, standing room only, where we went through the design of the problem statement, the solution design, and a little bit about why the Corda solution was different and dare I say it, better than the 2 other solutions presented. So that went down very well received. I'm not sure if that's online. Okay. And finally, we didn't just have a booth. We didn't just run workshops, but Dave Rutt was on a panel. We had a partnership workshop where we were talking through with potential partners what a partnership with R3 actually means and what value the partners get out of it. We had some partners present at that as well. We also did some swaps. For example, I presented twice at the Hyperledger booth to talk about some interoperability projects that we're doing with Evonym's sovereign platform, for example, which is part of the Hyperledger. I think it's Hyperledger Indy. So we were at the Hyperledger booth. We also we did a swap with HPE, so Hewlett Packard Enterprise, where we went to support them and help field questions about Corda on Nonstop, which is their solution for enterprise server hardware. And they would come to our booth as well and would cross-pollinate ideas, because Corda on Nonstop just makes sense. And there were cocktail parties and other fun stuff. Next slide. And that's it. Thank you.
Thanks, Anthony. And there was one question for you, actually. So for those that have questions, you can put them either in the Q&A window or the chat window. But it was probably a big one, Anthony. Could you please explain how Corda was better than other platforms for Ubin?
It's probably not something I can do on this call, but if you look at the design documents, that outlines the 3 different designs: the fabric, the quorum, and the Corda one. it's probably a separate session to talk about the ins and outs of why I think Corda was the best solution. But we managed to create atomic solutions to gridlocks. So gridlock is when, as I mentioned earlier, multiple people can't pay each other. But if you do some netting, if you do some multi-party netting, it turns out they can pay each other because they do have enough money. But I think we're the only design that could do a true atomic gridlock resolution all in one go, which either happens and clears the gridlocks or it doesn't happen, which of course is key. You'd never want to end up in a situation where you've half paid or half the gridlock's been resolved, but the other half hasn't been resolved, and you end up in a total mess. So that's the key takeaway from that. But there are a number of other design considerations as well, which I feel we had the edge in.
Very diplomatic.
Rich,
thanks.
I see on the chat, Rich.
Richard is a panelist. Richard can talk to it, so we'll make you a panelist real quickly here, Richard.
Okay, can you hear me now?
We can hear you now.
Oh, perfect. Yeah, so Anthony's spoken to that, but I guess a couple of other, well, just to emphasize one of them and then two other points. So first one was atomicity. I'm not convinced it was completely brought home in the associated documentation, but it's there for all to see in the source code. If you look at the Corda design, once the netting solution had been generated, so who needs to pay whom in order to solve the puzzle, so to speak, those payments, all of them, and the associated update to say the underlying obligations are now discharged, all happened at once, atomically as a single transaction with finality. They either all happened or they didn't. I don't claim to be a solidity expert, but my read of the solidity code was that's not how the quorum solution worked. From what I can see in there, each of those payments happened separately, and therefore some may have happened and some not, and only assuming they all had happened using the underlying zero cache security layer, the zero knowledge proof layer they have to use for privacy. Only then was a transaction executed that combined them all to say, yes, we now know that everything's done. So I need to do some more modeling, but my belief from looking at that is you can get into all kinds of really complicated and hard to recover from situations where some payments are made, some aren't, and then you end up in a worse liquidity situation than the beginning. So I think there's more analysis to be done on that, but the core solution was just so much cleaner. And then two other quick things was, because this may be a style point, but given this is fiduciary and fiduciary code that has to be auditable, understandable, and gain confidence of everybody. The difference in clarity of the code, the expressivity you can get from a mature high-level language like Java for the Corda solution, versus some really quite difficult to understand solidity and then when you look at the zero knowledge proof layer, code that essentially outside a very, very small cadre of experts would be impossible for anybody to understand. So in terms of the, it'd be like the maintainability or the operability of the solution, it was, in my view, it was night and day. So there's probably more to come, but I think there were some really quite significant differences.
Thanks, Richard. There is one other question. Charles has asked if there was, did the project Rubin assess which project had the advantage overall? Was there a conclusion to the project effectively? And he also asked if the Corda version of our solution was implemented in Java or Kotlin. And Anthony, I'm not sure if you have the conclusion part of that, and we can also talk to the Kotlin Java part on this side.
Sure. So deliberately, none of the documentation, there was no winner or loser. There was no ordering. It was very deliberately, it was three separate solutions with trade-offs and pros and cons, and they presented them, if you look at the document, very, very individually. So it's up to the user, it's up to the reader to determine what's important to them, and therefore make that judgment. So there was no kind of final assessment or placing.
On the implementation side, unfortunately, we don't have anybody in the room familiar with it.
Yeah, so it was worked on by Roger Willis and then various other people around the organization. So I believe it was in Kotlin. We generally write in Kotlin in-house. I mean, you can use both and they're both first-class citizens, but we tend to just find the Kotlin code more concise. But so I'm fairly sure it was in Kotlin, but as Anthony said, you can go and check out the source code online, which is in the MAS repository. So, so if you have any questions about the code, you can take a look there and then maybe come back with any questions on Slack or Stack Overflow. I think Java was mentioned in the context of, I guess, the integration with existing Java libraries and stuff like that. So obviously Kotlin can coexist with Java code, both in the sense of libraries, and also you can have a project that's written half in Kotlin, half in Java. So I didn't catch the exact mention of Java, but I'm guessing it was in that sense.
Also, for those that are attending on the Zoom, Clemens has put a link in to the source code that's hosted up in the GitHub. Excellent. Thank you very much, Anthony and Richard. So next up, we're going to have Guy speak. He's going to talk to measuring transactions per second. Transactions per second is something that comes up quite often in evaluating platforms. And Guy's been approaching how do we actually measure transactions per second in a consistent manner so that we can compare across platforms, and also includes things such as how do you define a transaction itself, and what portion of the system are you measuring in order to measure transactions per second to ensure that they're comparable across platforms. So Guy, I believe you are connected as a panelist, so we'll pass over to you and we'll progress the slides if you just give us an indication.
Thanks, Mike. Can you hear me okay?
We can hear you perfectly.
Great. Thank you very much. Happy to join. Appreciate the opportunity. Yeah, so this is just a quick, this isn't very long, but these are the topics I'm going to cover. There's been a shift in attention on DLT. I'll talk about that. Our directions with regards to performance. And then talk about what exactly are we measuring and some of the approaches to where we're involved in terms of standards and helping form those standards. And then just summarize at the end. Next slide, please. Right, so as I mentioned, this year there's been a bit of a tilt shift, if you will, towards operationalizing, or at least the term I call operationalizing DLT. We spent the past couple years or so looking at, well, what can we do with blockchain and DLT? What are we solving with this technology? But now that we have a better grasp of what we can achieve with it, the focus has been on, all right, how can we productize this? How can we make this production ready? And of course, that really gets into the non-functional requirements aspect. Includes performance, scalability, high availability, resiliency, operations management. How do you support all the operational aspects? So on the right, you see a snippet I grabbed from a Hitachi report I saw from 2017, where they highlighted from their observations some of the largest challenges, and they see number one was privacy, but number two is processing speed. So clearly there's been a lot of attention on this. It's not just my own observations. It's been a number of groups. So this is really starting with focus on performance. We'll go to the next slide, please. So our direction, now that we've got Corda version 1 open source out there. I think Mike in prior calls has conveyed that we organized the development team to focus on enterprise, but the team has been divided into specific subject matters, of which one is performance. And Rick Parker, I believe, is on the call. Hope he's on the call. Leads that performance team, and so I've been working with him because I'm sort of the outward-facing person. My role as a solution architect is to interface with some of you and customers and members and so forth. And so we built this practice, and to start with, we're learning. Everybody's learning. We're trying to build the practice, trying to establish some baselines. We're using Corda version 1.0 open source just to start to establish a baseline, because any of you or anybody who's ever worked in a performance practice team, you know, if you don't have a baseline, anytime you have changes coming that affect your solution, if you want to know, well, how has it changed performance-wise, if you don't have a baseline, it's kind of hard to figure out, you know, if you're better or worse. So you really do need to start to build a baseline. And to start, our Rick and team were able to see 120 transactions per second on a single signer with no notary, which is just a single-threaded open source Corda, just to use that as a learning exercise and to start to establish those baselines. And we're driving the things we learned from those experiences into Corda Enterprise. We want to develop a consistent testing framework, and we really expect to have full transparency on our testing methodology that we'll include and when we publish performance reports. And of course, we want to, you know, being that Corda is a little bit different than many of the other platforms that are out there, we want to influence the rest of the community as a community in general, blockchain DLT community I'm talking about, start to publish reports. And we want to kind of come together on what do these numbers mean? Are we talking the same language? So I'll talk about that in a little bit. Next slide, please. So I mentioned that, of course, we're establishing a performance baseline. We're working on that. And obviously, we want to, in order to figure out what to focus on in Corda Enterprise, we're looking at, well, what are the contention points? You know, in general, the industry's spending a lot of time focusing on consensus, because that seems to be one of the major places to focus. So, of course, we're seeing the same thing. So we're looking, when we're doing performance testing, we're considering some of these aspects, one of which is notaries, and that includes the protocol itself. You would know from prior AWG calls that Corda Enterprise will have a pluggable consensus. So we're looking at RAFT versus the variants of BFT, the number of notaries and the location of notaries. And when I'm speaking of notaries, I'm speaking of clusters. So in a notary cluster, it could be configured to use RAFT, or another cluster could be configured to use BFT Smart. And so when we say increasing the number of notaries, it's the number of notary nodes in a particular cluster. And when we talk about locations of notaries, any particular notary cluster could have virtual nodes geolocated anywhere. They don't all have to be in the same location. So we'll be testing what's the impact of performance where you've got nodes in a particular cluster that have large geospatial locations. So, you know, there's different types of testing we can look at there. We'll also be looking at what's the impact to performance as you increase the number of transaction signers, because that could possibly impact performance, as well as the transaction size. Because we know in Corda, one of the unique characteristics is you can, within a single atomic transaction, affect the state, multiple states in a single transaction, so they're all updated or none are updated. So we'll be looking at the impact of that, as well as the typical, what's the impact of the host environment of the nodes themselves? You know, is there IO bound characteristics? Are there CPU bound characteristics? So we look at what's the chip type, the number of cores, how much memory, what's the database configuration, all these typical characteristics that you'd measure in a middleware component. And finally, we'd be looking at all these things will be evaluated from an aspect of a business scenario. So some scenarios might have a different type of usage where the number of notaries and the type of protocol is used and the number of transaction signers, and that sort of thing. So the choices we make are driven by business scenarios, of course. Next slide, please. So this is just a picture representing some of what was listed in text in the prior slide. It's just there to describe in some of the notary aspects, the fact that our initial test that Rick and team did was just a no notary and a single signer. And then we moved on to adding a notary with signers. In the lower left, you see you have a large transaction with growing number of states included in the transaction. And then the lower right would be, as you add signers, what's the impact of performance? Next slide, please. So what's in a number? Well, I don't know about you, but I've been in meetups where I was in a meetup earlier this year, a blockchain-oriented meetup, where Don Tapscott was talking, and after he spoke, he went off to do book signings, and people were queuing up to get a copy of his book. And then there's a couple guys from a startup, a blockchain startup, did a little demo, and they were claiming tens of thousands of transactions a second, and we just sort of stared and like, my thought was, how are they claiming this? How are they measuring it? And there's all these questions that come to my mind given my background from middleware. And the person I was standing next to was shaking his head, thinking the same thing. It's like, well, I guess people can make all kinds of claims, and they may be legitimate, but we don't know. And the bullet point at the top, that was a different example. There was a DLT platform that published that they were claiming 80,000 transactions a second, and that was from over a year ago. So, and that may be legitimate as well, but we don't know. There's no transparency, which is ironic in an age where DLT and blockchain is all about trust and transparency. There's been very little of that when it comes to people claiming numbers. So, of course, from a sales perspective, somebody trying to sell their product and get attention, there's going to be a bit of exaggeration or puffery, and they may be legitimate. We don't know. So the point is, what are the common definitions? What's the guidance on looking and measuring from anybody who's trying to compare platforms? There's very little guidance there, and so people are maybe approaching it from their own perspective, and some taking different approaches. So there's no uniformity. So the question is, well, how do we measure transactions per second in a DLT world? So next slide, please. So from my perspective, and for some of the discussions I've had with others, and I'll talk in a little bit about what I'm involved with, we need to define terminology, and it seems simplistic. What is a transaction? What's throughput? But there's some nuances here when we talk about these definitions in a DLT world. And of course, we need to consider what are the number of nodes involved in a particular transaction? What's the consensus model being used of the platform, and what protocol is it using? What are the DLT components involved in the platform? They each have different types of data stores. They each have different intercommunication protocols between the peer nodes themselves. What are the underlying software and hardware environments that I mentioned earlier? The CPU, chips, the RAM and memory, and what's the horsepower of the environment itself? What use cases were they applying, and what was the workload they used to do the testing? And some obvious things, or maybe not so obvious things, is what was the testing framework and what tools were used, because some of us may know from experience that some of the tools used to do performance can actually influence the outcome of the performance itself. Is the test, can you replicate the test? Can somebody take a report, see how the methodology that was used to do the test, and can they attempt to replicate it and come to a close, similar result? And obviously, we should all be asking, well, that's all great. We're testing this and we're looking for the edge of the capability, but we need to compare that to what are our own SLA needs for the network and use case we're attempting to apply DLT to. Next slide, please. So in terms of standards and what we're involved with, I joined in October the Hyperledger Performance and Scale Working Group that was formulated sometime in the middle of the summer. So R3 is still a member of the Hyperledger project. And I reached out to Chris Ferris, who I know, and asked, is there something regarding performance that's going on? And he pointed me to this Performance and Scale Working Group. So I joined that. And this is, I'll let you read, this is their mission statement. But in short, the good news is that the team is trying to be agnostic in terms of putting together guidance of how anyone might approach comparing platforms from a performance and scale perspective. So by my joining the group, I could tell from the conversations, at first they were very blockchain oriented. They were focused on block sizes and things. And I kind of hope reset that to not every platform creates blocks. It's not the salient point. So we got that agreement. And then we started around, well, what's a transaction and how do you measure throughput? So, it's a really interesting discussion because now we're talking about how do you measure finality, because that's a very important point. So we're having really good discussions. It's a work in progress so far. But the team is includes me, includes people from Huawei who are on a different project called Caliper that are trying to create a performance measuring tool that they want to propose as a project to Hyperledger. And so they're on this standards board or this working groups with others from, say, Red Hat, from Intel. And these are people that come to this group with experience from their own enterprises of doing actual performance testing. So that's really helpful. So the main point is that they acknowledge the unique characteristics of different platforms, and they're trying to be fair in how we define things. So next slide, please. So as I mentioned, this is a work in progress, and what I list here are just what I've offered to the group in terms of we've got a draft outline paper where people are contributing. Well, here's what I think, and these are what I thought. And of course, it's not going to be completely accepted, but I can use this language to influence their thoughts. Some people come to their approach is more of a algorithmic approach in terms of creating a formula to represent and define a term, and I'm more textual. My main point in terms of transaction and throughput is there has to be some indication of finality. We have to know somehow that depending on the number of peers involved in a particular transaction, how do we know when the transaction was actually committed to those peers? That's finality. So that's a point that I've tried to include in the language and in our discussions with the rest of the members of the working group. But it's been a very helpful group. We're working together. We're all learning together. And these are things that are fairly common problems across any DLT platform. So it's very productive. And the next slide, please. So finally, just to summarize, we're working on with our new performance practice, building, establishing a baseline and building an appropriate testing framework. We're participating in the community in general to help establish the standards that will allow us to more appropriately measure. We're collecting your input, of course, so because we're all one big community doing this. And in the end, we're hoping to publish performance information on Corda Enterprise in Q1. So just so you know that. So that's all I had. I really just wanted to give you a sense of direction of what we're up to with regards to performance and scale. So we're trying to build a formal practice and influence the community in general. So that's it, Mike. Thank you.
Thanks, guys. Just a couple questions for you. One anonymous attendee had asked what reference business scenarios have been defined by the Hyperledger FWG. Do these include cryptocurrency movements?
No, we haven't got to the point where we're actually looking at those kind of use cases. And that's an interesting question. I hadn't thought about it. I wouldn't have expected the cryptocurrency aspect to come up, but now that it, when we get to those level of discussions, I'll bring it up, but I'm not sure that the group wants to go to that level, but it's certainly worth bringing it up. Good question.
Excellent. Thanks, Guy. So thank you very much, Guy. And if you guys have questions for Guy, you can drop me an email and I'll forward them on to Guy, or you can always go up to the public Slack channel. It's probably one of the best places, and you can tag Guy up there to have questions, interact with him directly. Next up is the Observer Node demo. So Joel, who is sitting right next to me, is going to take control and show us a demo of this new API that's been introduced.
Yeah. Hi, everyone. So my name is Joel. I'm part of the Corda Developer Relations team. So what I'm going to talk about today is this Observer Node API. So this is something that we've added in Corda version 2. So this is something we spoke about 2 weeks ago at the last AWG. But the idea now that we've stabilized the API in version 1 is that we can still add APIs. So we'll never change existing APIs. So your app can be ported very easily by changing the version number. But we continue to add new things based on user feedback from Slack and discussions we have. And in version 2, this is actually really the only really big piece of new API that we added. And it was based on feedback we had from various use cases. So the idea of observer nodes is, well, if you think in Corda, every node has an internal piece of storage. And there's various things that go in there, attachments, transactions, but the main thing probably is the vault, which is basically, in the early days, we used to compare it to the Bitcoin wallet. And so it's basically where you store all the states that you have available to spend. And you also store the history of those states so you can check where they came from. And up until version 1, and including in version 1, we had this model. So this is the one I've drawn at the top here. And so what happened is, let's say you hear about a transaction as part of a flow, then you record that transaction, you send it to the vault, and then at that point your vault will either choose to store it or to ignore it. And so if in version 1 it would store it if it was the owner or if it was one of the participants. And so participants are basically the people who are able to consume that state on the ledger. And what we found was actually there's quite a few use cases coming up where someone had a valid reason to store a state and to want to keep track of it in their vault, although they wouldn't expect to spend it themselves. And so you can imagine, I think the most obvious one would be perhaps a regulator or some authority wanting to keep track of what's happening in the system. So even though, let's say, they're monitoring bond trading, even if they're not expecting to buy or sell any of those bonds, they might want to see them move around the network. Another example might be, let's say, issuing shares on the ledger. And so the company who owns the shares might want to keep track of who owns the shares, even though they themselves aren't the owner of the shares. So there's quite a few valid reasons to do this. And so what we did in version 2 is change it so it's this bottom state here. So basically you can record the transaction, send it to the vault, and then still you're going to record it if you're the owner or the participant. But you might also want to record it if you want to observe that state. So it's up to you whether you want to be an observer of the state you hear about, and then you put it in your vault and it's available like any other state in the vault. So we're going to show you a demo in a second. There's just a few things to make clear about that. So one is that, obviously in Corda, this need to know data distribution is absolutely key, and this doesn't go against that. So it's not the case that you can join the network as a node and choose to be an observer of every state that's happened. You still have to be sent these transactions as part of flows to opt to observe. You can choose to observe any state you receive or any transaction you receive and start to observe its states, but you can't just choose to observe states from transactions you're not party to. The other thing is that in version 1, we introduced confidential identities. So this is the idea that you can, kind of like in the Bitcoin way, you can generate a new anonymous public key and then use that to represent your identity in the transaction so that only yourself and anyone you choose to reveal it to knows that you're involved. And this goes quite well with the observable states, because you can observe a state, but actually if the person who is part of that transaction has chosen to enter into that transaction anonymously, then even though you're an observer, you won't know who that person is. So I'll bring up a demo now. So I'm going to jump out of that. And so let me just share my desktop. And so if I bring up, let me just, can I move that around? Okay, I'll do this in Firefox. So I'm just going to show you the GitHub repository. So this is open source, and so it's on github.com/roger3cev/observable states, I believe the URL is. Yeah, so roger3cv/observable states. And so we've got a README here that explains what we're going to do. And what we're going to do is show an example of a crowdfunding demo. So I think most of you will be familiar with what crowdfunding is. The idea is you can start a campaign to raise, let's say $1,000, and then it runs for a certain amount of time, and over that time you take pledges, so people send, commit to spend money on your campaign, and if by the deadline you've raised more than enough money, then the campaign ends successfully and people have to pay, and if by the end of the campaign people haven't raised the money, then the campaign has been unsuccessful and no money is exchanged. Putting that in Corda terms, so we've got this as a transaction we've drawn here. So on the left, we have the input states. On the right, we have the output states. So this is how you start a campaign. And you start a campaign here. You've got this Rogers campaign output state and no input state. So this is, you're issuing this new campaign state onto the ledger. It's not taking any input. And this campaign will be broadcast around the network using the observer node feature. So no one really owns that campaign apart from the campaign manager here, which will be party A or Roger or something. But we still want people to have it in their vaults because we want people to know about this campaign and be able to pledge to this campaign. So here, and I'll show you how we do this in code, we opt to use the observer node feature so that people are notified of the campaign. Then you can make pledges to the campaign. So here, basically, you take the existing campaign, and here you can see £0 was raised. And then you move across, and here £500 is raised, and there's also this pledge of £500. That's how you do a pledge. So it's a transaction that consumes the existing campaign to produce a campaign with an updated raised amount plus a pledge. And then this is what happens at the end. And so either the campaign is successful, and you've raised all the money here that you require, and then the pledges and the campaign are exited from the ledger, but the cash is transferred from the parties who pledged to the runner of the campaign who's managed to have a successful campaign. Alternatively, it can fail and the campaign and the pledges are exited from the ledger and no cash is exchanged. So we can look at what that would look like in code now. And so I've got it open here in IntelliJ, and there's a few bits we can look at. So there's various flows and parts. I'll start with the states perhaps. So here we have two main states. There's this campaign state. So I'll bring that up quite big. And this is a standard state. So in this case, it's a linear state. And you can see here there's the name of the campaign, the person managing the campaign, which is a node on the network, the amount, the deadline, the amount raised so far. So, general stuff. And it's Corda, so these are very flexible. So if I wanted to throw in, like a val description of campaign or something and have that as a string, let's say, that would be fine as well. So it's a linear state that we're familiar with. It's also a schedulable state. And so schedulable states isn't something we see used that much so far, but the idea of a schedulable state is that you can have some point in time, in our case it will be the deadline, and basically when you have a schedulable state in your vault, it will periodically be checked, and once you hit the deadline, the scheduled activity will be kicked off. And a scheduled activity is basically just a new activity, a new flow that your node will start. So here we're seeing that a campaign is a schedulable state, and as soon as the deadline is hit, then we'll kick off this scheduled activity to start the end campaign flow, passing in this state. And so that means that the process of ending a campaign is actually handled automatically, and so it's not at the discretion of any, it's not the discretion of the campaign manager when it's kicked off, it just happens automatically on their node. And then also the other key one is we have this pledge state. And so again, just a standard Corda state, in this case a linear state, and a queryable state as well, so you can easily pull it out of your vault. And here we have the amount, the manager of the campaign, campaign reference, etc. And you can see here the difference. So the manager of the campaign is a party. So party means that they're a well-identified party. So they'd have a name that you could look them up by, so it'd be some organization's identifier. But then the pledger is an abstract party. An abstract party is a super type that can be anonymous. And so the pledger can either choose to go in as a named entity and disclose their name and who they are and what they're pledging, or it can choose to make a pledge anonymous and so generate a new public key that can't be linked to their other public key, and then pledge in that regard so that anyone who's observing the campaign won't know they're involved. And so the main other thing actually to look at then is the flows. And so the contracts, again, pretty standard, but here we have our flows. And so it's here that we're going to start seeing this observable nodes idea. So here we have a start campaign flow. It takes in a campaign that you want to start. Everything else is really standard. So here you're grabbing a notary, you're creating a campaign start command that's going to be signed by you, the campaign manager. You're going to create the output state, which will be the new campaign. And then you build the transaction, sign it, and run the finality flow. The only difference is this part here. So here we run this broadcast transaction flow, which is actually a flow we've defined. And the idea of a broadcast transaction flow is that this is where we're going to actually use the observable node functionality. So what we're going to do is we're going to grab everyone on the network. So you can see how we're doing that here. This is an artificial use case. So here, I wouldn't necessarily grab everyone. I could build up a list of parties based on some requirements or some known business network I wanted to use or some whitelist. But here I'm just going to grab everyone on the network except myself and the notary. And basically I'm going to run the send transaction flow for each person. So this is still being run on the campaign manager side. They've just created a campaign, they've stored it on the ledger. They didn't need anyone else's signature, so no one else was involved up till now. But now they're choosing to broadcast this to everyone else so they can record it as an observer. And here you can see the other side of that. So record transaction as observer. And this is kicked off by this broadcast transaction flow. So it's initiated by the broadcast transaction flow. And here it's very simple. I mean, this is really the only line in the whole thing where we're actually using this observer node functionality. Or we use it a few times in the other flows, but it's really this simple, where basically we're receiving a transaction as normal. We're using the standard flow for receiving a transaction off the wire. But in this case, we're saying states to record dot all visible. And what that's saying is we want to record all the states. We don't want to record just the states that we're a participant in or an owner, which would have been the default in version 1. Instead, we want to record every single possible state. And so that will make us the observer, and then automatically in our vault we'll have those states. So I can very quickly run through the other flows, but they'll be very similar. So make pledge, again, looks more complex on paper, but a lot of this is standard stuff. So grabbing a notary, we're extracting the campaign from our vault. So the reason we can do this, actually, this could be a completely unrelated party who's not the campaign manager. But because they were on the network at the time the campaign was started, and they chose to observe that campaign, they now actually do have this state in their vault, and they're able to extract that campaign based on its reference. And then they build up a transaction. Here you can see we're creating kind of an anonymous party. We add the various commands, the output states, the input states. You can go and check out this code on your own time, but just to highlight the important stuff, we go through the whole process as usual, collecting signatures, et cetera, et cetera. And then again, we do a send and receive, which basically sends it to the campaign manager. And it's the campaign manager who here, if you've chosen to broadcast to observers, so if you've chosen to make your pledge anonymously, again, we'll use broadcast transaction, which is that flow that we defined, to send it to everyone who can act as an observer and see the updates to the campaign. And then finally, there'll be some kind of end campaign here where a lot of the code here is around, extracting the various cache states that need to pay if it's been successful, canceling the pledges. But ultimately, again, we'll be using this concept of broadcast transaction to, again, notify people, even if they weren't the original pledges, to update their vault and mark this campaign as finished, whether it was successful or it was aborted. So just to give you, kind of show it running, instead of actually spinning up a UI for this, I'm just going to show you some tests we wrote. So we really recommend doing this for any Corda app you write. So basically here we're going to use what's called the Corda flow framework to test it. And the real benefit of this, I mean, is obvious. You, instead of having to spin up nodes and install the Corda apps on them and configure them and start them and then go and play around in a GUI or with a client to make them do things, by writing these flows, you can basically ensure that your Corda functionality doesn't break and test it without ever having to go through the process of deploying the node, running the node, etc. And so here, we're setting up this dummy network with 5 participants, A through E. We've got this Rogers campaign, which is run by A, which is, I'm guessing, Roger. And so just very quickly, and so here we have a, for example, flow test where we successfully start and broadcast campaign to all nodes. And what we'll see is that we can start the campaign. So you can run these flows yourself on your machine. And basically by running the flow, we start the flow here and we get the response. And we can see that once we've run this flow, it exists in the database of every single node, not just the original node. And this is because B, C, D, and E have chosen to be observers. So I can just very quickly run this test up here in IntelliJ. So it often takes maybe 10 seconds or so. And the reason is it's basically starting an entire network but of what's called mock nodes. So these kind of in-memory, very lightweight nodes act like real nodes and implement the same interfaces. And shortly those tests should be running once it's set up the network. So give it a second. And so the first test has passed and the second test will pass. And so there you go. So that's kind of testing. It would take us 5, 10, 15 minutes to do manually. But here, and we can see if we search in there that we successfully made a pledge and broadcast the updated campaign state to all the participants on the network. So that's the end of that demo. So as I said, you might want to grab the source code if you want on github.com/roger3cev/observable state. And I can drop a link on Slack afterwards if anyone's interested. And you can run the demo yourself then. So is there any questions on the observable node functionality?
So there is one from Charles, actually. Can I set up a handler to block a observed state and do whatever I want? Example, would it be possible to persist observed state into an external database outside of a node?
Yeah, so what you could do, if I jump back to the source code, I'm jumping out of this, you can see here that actually we've written our own flow to handle this. And so if this is the default flow perhaps, but if you didn't want to handle this in this way, if you wanted to write your own flow that responds to broadcast transaction, that's fine. That's what we expect in real Corda, right? So in a lot of demo apps, everyone will be running the same response flow, but in the real world, you probably will want to write your own custom one where you do your own validation or where you might put it in your own database. And so here, really, all you'd have to do is, before running this flow to receive the transaction, or this flow, I believe, would return the transaction. Let's say you got the transaction back from that subflow. I believe that's how that would work. And then here you could do whatever you want. So here you could get a database session, for example, and store it somewhere, or you could post it to some external web API, whatever you want. We do have actually, I mean, not as time to chat now, but we do now have a corda.net/samples page where you have a bunch of simple apps showing examples of this functionality. And one of the new ones we've added is this database access flow, which shows you how to interface with a database that isn't just the vault in the context of a flow.
Excellent. Thanks a lot, Joel. And just in the interest of time, we have one more thing to cover. Today, quite literally, is the anniversary of the open source of Corda. We'll just share a quick picture with this. So it has been a full year since you've been able to gain access to Corda open source. And I just had a quick picture to put on as we close out. So just a reminder, we have our next session for the architecture working group is in 2 weeks. We will not actually have a session 2 weeks following that. So we're going to take a break for the holidays, as we believe most people will be either out of our office or out of yours. So 2 weeks is our next session, and then the following one will be in the new year. So we will show you one picture as we depart, but thanks everybody for joining us. And this is the group at the cake cutting ceremony for Corda open source last year. So thanks everybody for your time. And if you have questions, etc., you can find us on the public Slack.
Thanks everyone.
Thank you.